Hey, Randy here. Shall we make a game? So last time we got basic pathfinding working, which is so hyped. Look at this guy go. Look at this guy go. It's going over here. There he goes. And off stream, I did a bit of an overhaul. So let's go over what that was. It's something that isn't really going to be finished until like the engine overhaul that's going to happen sort of after these streams. But if I go through to the matrix, yes, let's go to the matrix. There's now a dedicated type for a matrix, it's used everywhere, and also a matrix pair. Now the idea behind this is that quite often you'll be storing both the forward and the inverse of a matrix. And indeed, my reverse engineering, well, my sort of clean room reverse engineering is finished, so now we have the model matrix with its inverse, and also the projection matrix and its inverse. So, in theory, this means that we now have everything we need to take, let's say, a position in clip space and turn it back into a position in world space. All right. First of all, though, I need to go to, where's this image? There's like an image function here. So I have this, this kind of function that it takes a point in world space, runs it through a matrix, and then turns it into a point in image space. However, while that's very useful, there's definitely a case for, don't go blank. There is definitely a case for instead having it go through clip space in sort of like in the intermediate stage. So what that kind of means is, right, you have, like your world with your, I don't know, your pyramid on it. There you go. First thing sprang to mind. And then you have like a camera looking at it, and then basically you've kind of like transformed that world, so as if this camera was, from -1 to 1, 1, -1. You've basically like squished the whole world you can see into this kind of sort of cuboid that's been stretched back into a frustum. Right, so what we need to be able to do is we need to be able to take a point in here, say that we've detected we've clicked on something here, and we need to turn it back into that world. Now at the moment, we don't actually have the coordinates in here. Instead, we're actually flattening it down to the screen. So we're taking like, a slice, and then we're flattening it down to the screen. So it might be, like 320 by, I really should find a text tool. I think it's 320 by 180 our game runs it. But we actually want it in this -1 to 1 sort of normalized device coordinate space. So let's find the image thing in here. Yeah, this should instead be calculates the coordinates of a 3D point in clip space in normalized device coordinates once a matrix is applied to it. Simple enough. We can get rid of that and that and that, and we can instead pass in. Oh, I might just go. I mean, let's just check the name. Let's just check that the meaning of this is what I think it is. Homogeneous clip space. Now that is a those are words. Yeah. So yeah, view space. That's kind of like where you're sort of like applying the camera to it, but like not the lens. Projection matrix kind of applies the lens, and then we do the viewport transform, which is kind of the final step that turns it into real pixels. So I guess we call it clip space. So rather than being matrix image, it's going to be matrix clip. Calculates in clip space. What's a model view projection matrix is applied to it. There we go. Okay, so we're going to have let's call it model. The point in the 3-dimensional point in model space transform. And we get rid of all these. We don't need to know the size of the images because regardless, it's going to come out the same thing. Yep, that's good. And so I'm not actually sure what you actually do to, other than calculating the inverse of like the projection matrix. I'm not actually 100% sure what you do to unclip something. It might actually be the same thing, but I don't know. Okay, and I'm going to end up with, go to these two. So we're going to clip space. The three-dimensional point in clip space overwritten with the corresponding three-dimensional point in clip space may be model. It's just so that you know, here you can reuse a variable if you want to. Okay, there we go. Got that. Stick that in there. And in the meantime, we're actually going to take this and yeah, we can reuse this pretty much. Yeah, we can actually call this from in here and have it still present the same API. So let's grab all that out. Yeah, we need to account for the point being clipped. Okay, so we have a W. Now we're calculating C by dividing it by the W, which will give us a point in 3D space. Well, it gives us a point in clip space. And stop saying 3D space, it means nothing. And then we can get our X and Y. When the point is clipped on W or Z. Yeah, I should probably make that clearer because it doesn't. It could actually be off the edges of the screen, but it's actually fine because you can have, say, a triangle stick out of the screen, but that's kind of fine. As long as it doesn't stick through the screen, that's where you get an issue. Okay. In fact, we're probably going to get rid of this longer term, like entirely, because in the engine overhaul, I want to make cameras a component, which means that this isn't going to be a common operation. And also they're going to have different viewports. There's not even going to be like a single one to work with. And you might actually, for say split screen games, only have part of the screen being redrawn by a camera. So they're not going to take up the entire image, just parts of it. Anyway, you could actually have several image structs that overlap in space, but we're not going to do that. That'd be silly. Yeah, what was I on about again? Yeah, that's right. Just renaming these. And that should be model. Model is one of those words that means so many things in computer science that it's actually meaningless. Like even just within the web development sphere, you've got. I mean, even within MVC frameworks, no one can agree on what model actually means. In, for example, Laravel or kind of related frameworks, a model is literally just something in your database, but it's a kind of a class representing something in your database. Whereas in ASP.NET MVC, a model is indeed actually something that kind of defines what can be received by a. It's almost like a request or a response object, sort of. Kind of the closest way I can think of describing it. Okay, so. Yep, that's all good. That's all good. So we've got X and Y, and now we just copy them over, I guess. In fact, we can just write it right there. That won't be the end of the world, would it? No, let's calculate it instead. There we go. That should work. And then this can call into this from here. Actually, I wonder if this should just return or if it clipped it or not. That would actually be like way easier to check, wouldn't it? Value is not overwritten. Okay. Why didn't I do it like this in the first place? Why didn't it just always return a value? Anyway, true when the, doing that. True when the, true when the point falls between z minus 1 and 1. Otherwise, false. Actually, let's reverse that. Overwritten with the, okay, when the point's not clipped on Z or W, otherwise false. Okay, that'll do. Are we bringing in the Boolean header here? No, we're not. Yeah, it's kind of design thing I'm kind of considering is kind of like when this engine gets overhauled, it's just making a single massive header with almost everything in it, because it's kind of annoying to keep tracking all these headers, and I don't imagine that for many of the common things it's going to make that much of a difference to compile time, right? Surely not. It's a complaint because I haven't run it. Okay, and return false because that's been clipped. Return false because it's been clipped. Otherwise, return true because it's good. And I'm going to make the same design change to this, actually. I just don't know why I ever did it like that. Pass its model and model view projection matrix. Okay, and then we've got rows and columns, which is the dimensions of the image. That's fine. And I'm going to keep those separate because they're kind of meaningful in the way these aren't. You know, I'm going to move this out of here entirely. It doesn't belong. Just going to get rid of it. It's to do with images, really, not matrices at this point. I mean, there's not going to be any matrices going into that thing to take like a clip space coordinate and map it onto an image. Where does that belong? Because it kind of belongs in images. I'll put it in images because it is, you know, if you're calculating viewport coordinates, it's going to end up in an image eventually. Okay. Image space from. What am I going to call this? What am I going to call this function, man? I mean, because image clip sounds like you're modifying the image, like you're cropping it or something. What do they call this? Screen space. Image space. Let's just call it that. converts a given coordinate from clip space dimensional clip space to the corresponding coordinates on an image. And let's put some useful helpers in here, like say offsets on the left and top here. Hang on, thinking. Okay, top rows. So we're gonna have like how far from the top. We're gonna have left columns, which is gonna be the distance on the left, and we're gonna have the width and the height. So rows and columns, which is height and width, but you know what I mean. And then we're gonna have, all these are gonna be constant as well, because why not? And we're gonna have our clip space coordinates. And this is going to be dead simple. It's going to be, oh yeah, we're also going to have the outputs. That would make sense as well, wouldn't it? And C pointer const. I'm going to have to look this up. I have to look this up every time. I still haven't internalized it. We'll do eventually. That one. So it's F32. You can change the job, but you can't change the point. Okay, right. Ooh. Because I'm going to have an output rows and a width of the viewport in rows. How am I going to name these differently? Fine, I'll just call it viewport rows, whatever. Okay, so it's going to be the top rows plus the viewport rows, and let's cast those two floats nice and early. Actually, let's have all these as floats. Why not? Why not? At least that way we're kind of like minimizing our casts, probably. All these names are getting long again. What am I doing? Okay, viewport top rows plus the, hang on, viewport rows. So start at the top and then we're moving down halfway. Hang on. Yeah, there we go. That's right. That ended up quite simple. It's kind of interesting how splitting that function in half made both halves so it's simpler. It's going to be more complex to call it, but it's both halves are simpler. Okay, let's document all these. Number of rows between the top of the image and the top of the viewport. Same thing for columns and for left. Number of columns between the left of the image and the left of the viewport. And then we've got the rows, which is the height of the viewport in rows. The width of it in columns. Okay, so, and then we've got the clip point, which is the three-dimensional point in clip space to transform into image coordinates. And then we've got the rows overwritten with the resulting number of rows between top of the image and the transformed point. Ah, not transported, transformed point. And we've got the same for the columns. That's the image and the transform points. Okay, there we go. Ah, damn it. I realized if the idea would help me out here and just, like ultimately crunch it into the ruler, that'd be nice. Anyway, I'm gonna take that and put the implementation where it belongs, because that was not where it belonged. Okay, very good. And what's this complaining about? Array of void is not allowed. What are you talking about? What do you mean by this? Let's press make and see what happens. Best case scenario, it throws an error at us because we just changed an API it's used in quite a few places. Yep, there it is. Okay. So we just need to call into matrix clip, which will give us the, we'll give it the location of the image component, because that's what we're editing here. We have the matrix that's being applied to that location. And then we're writing it back out to the clip. And then to get this row, column, and depth, where's the depth coming from? Oh, it is actually used, okay. Oh yeah, it's used to, you just can't draw them in the right order, I think. Or is it only used to, I think it's only used to sample them in the right order. I think it's actually used to draw them. Okay, so we've got the matrix clip, we've clipped it. So next up we have to calculate the exact coordinate on screen. We can use clip 2 there. And I think it's image space, was it I called it? Yeah. So we're going to use the exact dimensions of the entire buffer, because this version of the engine isn't going to support anything fancy like multiple cameras. That's coming later. The clip space coordinate, and then we have our rows and our columns. Oh, it's just occurred to me. Oh, I named that wrong. I'm gonna have to fix that now. Arrgh. That should be row and column, because it's not a quantity. Naming things really is one of the hardest things about programming. It really is. That old meme and joke is 100% true. Okay, and then we just need to make the corresponding change on the other side. Almost there, and then we can go back to finding what we broke by making that change. Get rid of this now, don't need this. And we can actually skip that entire second half if we, yeah, we can do this. Still need this though, because it could be clipped, in which case we need to make a record for the rest of the code knows not to touch it. Okay, next bug, if you please. Oh yeah, my wish has been granted. This isn't a 3D line drawing code, so similar kind of affair. We need to basically do a matrix clip. And then Windows can open a random window. That kind of works for me, I guess. Almost the exact same code. You can probably see why I made those two things one function, given we're doing it very frequently, but that's going to change soon. So we've got the origin location, and we've got the model view projection matrix, and we've got the clip. We also need to, we've got an origin clip and a destination clip now, yeah. And all these if statements can just go away, we don't need them anymore. Oops, I didn't mean to do that. Okay, is that going to be happy? Okay, moving on to the next bug. Next bug, if you please. Oh yeah. Rather than, transforming the start and end of the line, I just transformed the start twice and the compiler caught that. Thank you, compiler. And now we're onto our mesh, which is the next one that should be using that. Yeah. So the complexity here is that we're basically like ripping through the entire list of triangles in the mesh in kind of one go. Meaning that if we don't store the... Yeah, just figure out how I'm going to do this. How am I going to do this? So I'm basically like ripping through the entire mesh in one go, and then I think I'm doing the actual comparison down here. Yeah, I am. Because I have to make a separate array of booleans, which should be very inefficient, or I basically just replicate what this used to do. So let's go matrix clip, and then we're going to take the vertex location, apply the matrix to it, and then we're going to write that back to a temporary over here. We're going to make a new temporary kind of variable. Okay, and we've got our destination rows, no destination columns. Actually, I wonder if you could like construct a matrix, like a projection matrix to make it so you don't actually have to do the viewport transform. Kind of, if you could bake it into the matrix, that would probably speed things up a lot. Should put a note in there. Actually, I should put a note in there. To do, bake the top left into the projection matrix instead. We can just, save an extra kind of like addition and all that stuff. Okay, let's see if that builds. Oh yeah, I've got separate code down here for actually sampling it. That's right, I remember now. Can probably just copy paste this, right? Oh, it's building. It's building. Let's just do a parallel build, given it hasn't crashed yet. And I'm going to reboot the engine from the start because I have modified, I've tampered with things that probably affect things that we can't see on the screen. So it's storage, little storage, delete this out. Well, this isn't working. Oh, I wonder why that isn't working. Oh, hang on, I've interleaved these. Oh. Okay, let's correct everywhere I've messed up. Yeah, because I actually made the function top left height width, and then I've used it as if it's top height left width. So I end up with like a bunch of things that are 0 height, which is obviously wrong. Okay, let's see if that fixes things. Should compile nice and quick because we've just added some C files. No, that didn't fix anything. Okay, let's keep looking. This is somewhere else really obvious that I've messed up. Oh! The text boxes are appearing. Well, that's something. Okay, what have I broken here besides everything? Is it possible I've broken something in here? Something kind of subtle? Let's have a look. Let's have a look. See if there's anything like really obviously wrong with this. I'm not seeing anything. Yeah, I'm not seeing anything obviously wrong with that. Still doing all the kind of like various dot producty stuff, all the goodness between the point in 3D space and the matrix. So that looks good. What have I broken here? I've definitely broken something. Let's have a look at all the usages of this. Is it definitely... Let's just get through to the maze. Let's see if we can get to up here. Once it puts stuff in local storage, animation should play. Come on. Okay, now we can jump through to a different scene. Okay, so we know it's not just meshes that are broken because we can't see the nav mesh. It must be something pretty fundamental I've messed up here. Let's have a look at the diff. Let's see if anything jumps out and we have a look at the diff. That all looks equivalent. That all looks vaguely equivalent as well. All right, next up, let's focus on meshes. Meshes are the one that are used basically everywhere. So we've got the mesh layer function. We're checking whether it has a clip, and If it does, we are overwriting the... Oh, I see, I see what it is. I had this sort of pointer math that kind of advanced it to the next item on the list, and I seem to have gotten rid of that somehow without realising it. I bet that's not helping. Oh, and now the world's upside down. I know why that's happening. Let's go to the image helper. This should be that. It's that age-old confusion where like bitmap graphics 0 is at the top and in kind of like game graphics 0 is at the bottom. So what do you know? This looks like it's working again. Okay, I'm going to commit that as it appears. It appears that I've mostly recovered from whatever I just broke. Yeah, I can't wait to have a really good overhaul of this. Really get my fingers into it and really clean it up. Didn't I add a mesh component? Oh, no, it didn't. Okay, right, okay, good. So how am I going to describe this change? Separate clip step. Right, and then we go through to our selectable components, and it's going to be a bit in here where we're basically figuring out what you've clicked on. Yeah, so we've... Yeah, this here. We basically need to pass through a bit more information about exactly where you are in the scene. So we can calculate that pretty easily, but first of all, I'm just going to go into this callback type and I'm going to give it an argument for the position of the scene. Yes. The three-dimensional coordinate of the surface clicked on in the scene in world space. Okay, are you happy with that, Visual Code? You're going to get rid of this red underline? No? Fair, okay. Well, that will have broken everything because quite a few places use that. So, yeah. And we don't need that we don't need to know where we are in 3D space for interacting with a 2D menu, so let's just void that off. We're never going to use that. Yeah, this list component's really useful. I'm not entirely sure if it would make it into kind of like the rebuilt engine. It's something very specific to this kind of game, really. Okay, let's keep building. It's now going to complain that we're not passing it in. That's fine. So now we're going to hang on a second. We're going to get the we've got the depth, and we can now do our reverse transform. Temporarily though, I'm just going to make it so it's so make it go to something irrational like 0, 0, 0, just so we've got some information to work on. Just so we can keep working for these errors and get it building again. It's going to be a lot of these to fix. Oh, that seems to be building. Okay. I'm just going to pause that and do a parallel build, given it isn't encountering any immediate errors. And next thing I'm going to do is going to the script, movie theater, and I'm going to make it move the cube to wherever you've clicked. It's looking good. If we can get that that reverse transform working nice and quick, we should be in a good position. So we create our a target entity. And wouldn't do this for like normal code, but we can just yank out the entity here. Oops, yank out the transform matrix here. Lost some place. Where was I? Here it is. And it's the target entity ID. And then we've got a matrix model, and we can use our world coordinates. Not going to rotate it, and we're not going to scale it. We're just going to overwrite that with that, and then that should yeah. I did read a thing saying, oh yeah, array type def with array in C is kind of an anti-pattern, and sometimes you have to do like unintuitive stuff like that. It does work. It's just kind of unintuitive that this doesn't actually, because when you have like an array type like returned like this, it's actually sort of a pointer, but kind of like a doubly wrapped one. So you get a pointer that's pointing to this matrix in memory, but it's not an array at that point. It's an array to a pointer. So it's a pointer to an array, but the pointer is the array. They're not really distinct concepts, but you kind of have to dereference it, even though that does literally nothing, just because it kind of like satisfies the rules of the C type system. So let's make it so we can click on the world. So we're going to want the click callback, which is the last one. Oh, that's good. Okay, so should be a click, and that should be moving. Okay, next up, let's put an IE error in here, just so we can make sure it is actually doing things when we click on the background. Oh, it helps if you actually build the game too, generally speaking. Come on. It is not picking up on our clicks. That's interesting. Why isn't it picking up on our clicks? That's kind of really weird. Oh, wait, I have the thing in here saying whether it's selectable or not. Yeah. There we go, now it's crashing. Now it's crashing just like we expect it to. Okay, the cube disappeared from there because we clicked on here. That's kind of expected because it's going to 0, 0, 0, which is down here, it's off screen. So next up we want to, when we select, we actually want to calculate this world next. So, all right, this is where things get a little tricky, shall we say. Now at the moment, the camera doesn't really expose its kind of location. like at all. Do I put it in here so you can get to it? I'm going to have to. I was really kind of hoping to avoid this, but I can't really avoid it. Okay, all right, okay, we'll deal with it. We'll make it happen. So actually, something I'm just going to check first of all. There's something I wasn't quite sure about when I was working on that matrix math stuff the other night, well, last night. And that is that when you multiply a pair together, do you necessarily multiply them in the same order? So I'm going to test first of all that our actual pairing here actually works. So to do that, I'm going to come down to here and I'm going to give it an input. Let's just put something nonsensical here. It doesn't really matter. Actually, let's pick a point that'll actually be in sight. We can probably just grab, like, say this. That'll do. So we know that point should be visible, so it won't get clipped out or something. And then we should then be able to clip it with the forward matrix. So yep, that's good. And I put that to the clip. And then, if I'm correct, we should be able to undo it the same way. If I'm correct. And it should give us a vector that's very close. It might not be exact, and the reason it won't be exact is that there'll be a tiny amount of like rounding error and stuff, but it should be near enough perfect if it's correct. So then we should be able to go from input to clip, and if it's, don't need to initialize that, we're going to be initializing it in a second. Right, this will give us an idea of whether our approach is even valid, because I have absolutely no idea. Oh, didn't like that. Oh, I need to tell it how many axes there are on the on vectors. Yeah, I'm definitely hard coding that in the engine overhaul. Build. Wait, did I not do a parallel build? I didn't do a parallel build. Okay, there we go. Run. Okay, we know our coordinates didn't match up in that case, so it's entirely possible I have to swap these around, or there might be something else I need to do. Hang on. Yeah, be A and B. I'll be swapping around, not B and A, not whether they're the forward or inverse. Okay, that didn't work either. I was kind of afraid of this. Okay, so now we need to get these numbers out. Well, that's going to be a pain. Let's make these externally available, and then I can put some hacky output stuff in the advanced callback and see if we can figure out exactly what numbers we're dealing with, see if we can spot a pattern of what's wrong. Matrix pair. That's going to be eye camera model view projection. Yeah, that'll do. No, hang on, it's not a model view projection, it's just a view projection. The model doesn't exist here. Okay, and then that view projection matrix can go. Okay, that should be good. I'm just going to comment that out of there and make sure that we can... Oh, I changed the header file. I need to rebuild everything. Go faster. Yeah, I kind of don't like having that kind of publicly visible, but I don't really see another way around it. Okay, all right. So next up, we need to go to our advanced function. The reason I need to do this here is the lines don't currently pay any mind to depth, so I need to draw them last if I'm going to draw them. So text overlays, that is. So let's import fonts. I'm going to want a small font. Yeah, that's good. Grab this, put it in here, and then we're going to get rid of that. And this is where we can start writing some stuff on the screen. So reset the font buffer. Come on, I want this to work tonight. I don't want to have to leave myself in suspense of whether I'm going to solve this or not. That needs to be a pointer. Then we're going to, oops, font layer onto the view and I can't type. Let's go for some white text. I want it to stand out against the background. And then we're going to go to the video buffer. Okay, this should write the word test in the corner. Yep, there it is. Okay, so next up we're going to write some things to help us understand what's going on here. So I'm going to put input, put a new line in. Actually, not yet. So we're going to input, and then we're going to go for, I think we've got like a thing here to write a signed. Yes, we do. And then put 0, 1, and 2. Put some commas in between them just so we can read them more easily. And then we have a new line at the end. Okay, and then we're going to do the same thing for the forward clip. Oops. Okay, let's see what that looks like. Ah, right, okay. I'm just going to multiply these all by like 100 because they can only be integers. They're being kind of like automatically rounded down from floats to integers. So these kind of like tiny fractional coordinates are being lost. Let's just scale them up so we can see them as integers. So yeah, we're seeing pretty useful stuff here generally. Now, what happens when we unclip it? There's a good chance we're going to see some scary numbers here. So viewer discretion is advised. Yeah, that's kind of weird. That's not what I expected at all. Those are some really tiny numbers. I'm glad I chose like a large scale factor, or else it would just come through a 0 and I would have been very confused. Okay. Inverse projection matrix. Application. Do I need like a different... No, I'm not after homeopathy. DuckDuckGo. Now, I'm very certain this matrix is correct because the implementation had test coverage and matched pretty well with what Blender was doing for the same input. Okay, what was the term I found for this the other day? It's going to be whether or not you do we divide clip inverse. Ah, here we go. You don't do the exact inverse. Okay. What? You have to read something, you're just like, this is above my station a bit. In strict mathematical sense, you don't do the exact inversion of the forward transform. You could do the exact inversion if you had the clip space W value for the NEC point, that's clip space point you want to project back. Actually, you can undo the division by multiplying by W. Okay, yeah, that makes sense. As to multiplying with the inverse projection matrix, you get the original point back with the original W coordinate you put in. Okay, so what they're doing here, they are doing to the power of -1. To the power of -1, hang on. I'm trying to remember what to the power of -1 does. It's been a long time since math class. Hang on. Because doesn't like that give you 1? And then, does that mean it's actually like, yeah, isn't that like, it's the reciprocal. Okay, okay, all right. So we're gonna need a new matrix helper and it's gonna be unclip. Okay, the coordinates of a 3D point in what's an inverse. And I'm not going to return anything. We're assuming it's already in kind of like a correct space. I'm going to swap these two around. I'm going to call it unclip. Why not? Okay, I'll put an underscore in there for studio code. Does that make you happy? To be fair, I think that's the gspell extension, not the not the studio code itself being pedantic there, but the point stands. So yeah, we multiply the matrix first by the points, and then wait, projection. Yeah, that's the inverse of the matrix. Okay, right. So the only difference is hang on. No wait, that is the exact equation we're looking at. Yeah, okay, so they're saying that's not how they're calculating normalized diversity coordinates from world space. That's how they're calculating from viewport coordinates. And then they're using the inverse model projection. Okay. All right, okay, I'm just going to comment that out as I don't think it's necessary. I misunderstood the Stack Overflow was reading. Let's do any of a make because that will have changed. That will have changed the header file. That will anger make. Wait. Oh yeah, I haven't implemented this yet. That's fine. Okay, so let's have a look at the camera. Let's try swapping. The two things I was considering swapping, where are they? Here they are. Oh, I swapped the wrong two round. Because the camera uses the other two. And we've got the run clip coordinate back in. Okay, that's good. Okay, how often do we actually do this operation? I don't think we do it that often. Yeah, we only do it in the camera stuff. To do, rethink this ordering. Yeah, rethink that. And the reason I'm saying rethink it is I'm pretty sure the camera code actually swaps them around. Yeah, it does. The camera code swaps them around. We'll think about that some other time. So it should be good to get rid of all this. In fact, let's see if we can roll the whole advanced thing back. With the exception of navigation mesh, we can't need to be able to see that. And we can also get rid of this. And this, we don't need these. Oh, that is a very nice feature of Visual Studio Code. That is being able to just like drag over something and be like, yeah, stage that, unstage it, whatever. Very nice. Okay. So now we should be going through that selectable component class, and we should be able to calculate our world position, which is going to be basically doing the opposite of the image spacing. So I might actually add an image unspace. I guess that kind of works. Converts a given from coordinates on an image to the corresponding okay, all right. The number of rows between the top of the image and the point in. So I was just thinking about that. Yeah, it is definitely in yeah. So I just really thinking really hard. Hard to believe, I know. I'm just an optimization I could do with mesh picking. Not transforming them into screen space, just keeping them in clip space. I imagine there probably is. I should make a note of that. To do, we might be able to optimize here. By staying in clip space. Additionally, to do things don't Dave have depth anyway. Okay. Number of rows between the top of the image and the point in and the points being transformed. Yeah, I want to keep going until I got this solved, because we've got to be pretty close. Overwritten with the resulting point in three-dimensional point in clip space. Okay, so make sure these match up. Left column, clip needs to go in the bottom, needs to be non-constant, and these need to change the pointers to values. Man, I hate calling this unspace, but I'm gonna do it. And it's basically going to be the inverse of this. So we're going to, oh, I need to pass in the depth as well, don't I? Actually. I think going to be the first two components we're actually modifying, so we can just overwrite the first two and then just leave the third one to be, you know, as an exercise to the reader. Easy. Okay, clip 0 is the row. Hang on. Take 0.5. And then multiply by 2. And then we also, no, hang on. If I start doing these a lot, I'm going to want a reciprocal instead. Oh my god, I can blank. No, not a good time for this. That's 2, that's 1. Let's make it explicit, they're meant to be floats as well. The other thing I'm going to want to do is that, I think. Because remember, the image and world space are kind of upside down relative to one another. It's very confusing. So clip is going to be that, and then clip 2 is going to be the depth. And I'm going to unclip image unclip unspace. Yes, that was it. And do we have the mouse coordinates in here? Yes, we do. Pointer rows. No, hang on. These are the viewport coordinates. I'm making that same mistake again. We're going to have them in here, right? No, are we not going to have them in here? Oh, there we go. Columns, and we have the pointer row, pointer column, and then we're going with the array. It's not happy about something. Oh, it doesn't know what this is. Fair. And these are in plural for some reasons, but in fact that's wrong. And then we're going to do a matrix clip. Use the camera. I don't import the camera here. Let's bring it in for the first time. And I think it's going to be 0. I think it is. And what are we doing here? We're getting the model V projection matrix. I've done that wrong. Okay. Oops, helps you spell that right, doesn't it? Let's see if that works. And I've changed the header file, so I need to do a full rebuild. Come on, come on. I want to click and see that cube move. Let the cube be free. Oh, we are getting coordinates, but they look a bit wrong. Okay, just for a bit of fun. I'm going to here, and bitrate defines a target. I'm going to change that. Where's the bitrate grabs the matrix? Here it is. Instead, we're going to populate that from the target model matrix. So that's 3, 7, and 11 to get the position. But there's 2 matrices. We want the first for all of those. Oh, it doesn't like that. Does it like that? I think it does. I think I know what the problem is. Yeah, it's going to have to be like that. Because it's a pointer to an array, right? So you're basically following the kind of pointer to the exact same space, and then you're then going through to which matrix inside the pair, and then which element of it. So yeah, the cube is now following the other cube. So if I place it over there, it should chase around to like there. Yeah, because that's the nearest point. Okay, so it is now chasing the cube. Everything I have to do now is fix the fact that it's not actually placing the cube correctly. Nope, that's also wrong. Oh, damn it, this was working. Okay, all right. Just gonna bring the, just gonna make it, I'm gonna make use of the very healthy undo buffer in here and just see what I actually did in here. Yeah, I went from clip space back to put it through 0, so that was correct. So yeah, I'm putting it through 0. So there might be an issue with this on space. In fact, I would be very surprised if there wasn't. Okay, so let's draw this on some paper, shall we? Well, not some paper, but so we have our screen, right? And then we have a viewport within it. And then we have a coordinate that we're trying to calculate. So we get the coordinate minus the top of there. Okay. So let's say that this was, 100 tall. And let's say that the distance from here to here was 30. Okay. And let's say that this was 50 tall. And let's say that this is at 45. Okay. So we've now got 15, which is the length of this. And then divide it by the number of rows, so it's the height of this. And oh wait, do I have these backwards? I think I have these backwards. Yeah, there we go. Why can't I click on these chairs? That's kind of interesting. Anyway, Or here. It seems to work here, but not like here. Might have a few bugs there. But anyway. Yeah, it's going to kind of like chase around to... Should like reach there and kind of go through there. Oh, I know why it's not moving. Because the closest point on the nav mesh is there and it probably has line of sight from over there. Yeah, it's only working in some places on the screen and not others. That's kind of interesting. Okay, so it's definitely tracking nicely all over the screen. It's just that it seems to be having... Okay, the extremes on the left and right is fine. It's just when you get past here, it seems to go a bit wrong. That's a bit weird. And is there a point at which it goes wrong up here? Yeah, it's like there. So whatever this bug is, it just so happens to line up nearly perfectly with the layout of our map. Well, I'm going to stop there because that's way over my normal time. We made some progress on this. We've definitely made some progress. Hopefully tomorrow we can squash that bug and maybe get a character animating. And maybe we get this sort of like, you know, dressed up a little better so it's got a character kind of walking around. So we can have them sort of chasing wherever you click. Until then, have a great evening.